We've seen that the sun heats up the Earth. It's clear that the heating is a lot stronger at the tropical latitudes. In this way, low pressure and anticyclonic areas develop, depending on the warm or colder areas of the Earth's surface. We've also seen that the troposphere has an altitude of about 10,000 meters, reaching even 12,000 meters, while around the poles it's from 6,000 to 8,000 meters, and the tropical regions even 16,000 or 18,000 meters. It's clear that a thunderstorm developing near the equator would rise to a very high altitude, up to the top of the troposphere layer. This is why in that region you find equatorial low-pressure areas, where the thunderstorms are extensive and at high altitude. The heat absorbed at the tropical latitudes is in this way redistributed onto the Earth's surface through connective cells on a large scale. These are the famous Hadley cells, from the name of the first scientist studying this phenomenon. In the southern hemisphere, there is another anticyclone on the Atlantic Ocean. It is called the St. Helens High, around which the wind circulation is anti-clockwise this time, under the effect of the Coriolis force, which reverts its moving direction in the southern hemisphere, where we will have trade winds from the southeast. This is what we call a convergent zone. ITCZ stands for Intertropical Convergent Zone, where the two intertropical airflows converge, giving way to an extremely unstable area with huge thunderstorms, irregular winds and doldrums, difficult to navigate even for boats cross-sailing the areas. Across the oceans around the world, and depending on the large weather systems generating the wind circulation at low levels, more or less favourable routes have been statistically thought of. These are highlighted on the charts, known as pilot charts, which allow you to plan a route across the oceans some time in advance.